Good day, students. Welcome to the clip where we're going to be reviewing the law of cosines, sines, and also the area of a triangle using triangle trigonometry. So let's take a look at question number one. So for number one, we are to solve the triangle. Solve the triangle with the given measure. And for number one, what if we have a triangle with angle C is equal to 89 degrees, side A is equal to 8, and side B is equal to 14. Okay, so let's go ahead and draw the triangular situation representing this problem. So let's just draw any arbitrary triangle. All right, and let's label the angular measures. Let's call this angle C, which is 89 degrees, and let's call this angle A. So that'll make this side A, which is 8. Side C, we do not know what it is. Let's call this angle B, and then side B, which is 14. Okay? All right, so to solve a triangle basically means we need to figure out the values of the side lengths or angles that are not given. So big A, big B, and little c. Now, what kind of situation is this? This is an SAS situation. Okay, SAS, side angle side, you're provided with two sides and an included angle, so it's a side angle side situation. If you're solving a triangle using side that is side angle side, you have to use the law of cosines. Okay, the variation of the law of cosines we're going to use here is c squared equals a squared plus b squared minus 2ab cosine c. All right, the reason why we chose this formula is because the problem provided us with big C. Okay, so let's plug in the values of A, B, and big C into the formula. That will help us find big C. So what we are trying to find here, we want to find little c. Okay, so finding little c with the law of cosines, we're going to have c squared equals 8 squared plus 14 squared minus 2 times 8 times 14 cosine big C, which is 89 degrees. Okay, so we're going to enter this into our calculators. All right, so let me set my modes to degrees first so that everything is accurate since we're dealing with degrees. Mode in degrees, enter. So we're going to calculate 8 square plus 14 square minus 2 times 8 times 14 cosine 89, and our answer is going to be 256.091. Okay, so let's go ahead and write that down. C squared is equal to, was approximately 256.091, and to get c isolated, little c isolated, we'll just take the square root of both sides, root this and root that, and then we'll have little c is going to be approximately, let's enter that into our calculator, that's really close to 16 there. So we're going to do the square root of the answer. So let's just enter that back, close it, enter, 16.0028. All right, so little c is 16.0028. Now let's put the value that we just found back into the triangle so we can know what we're working with. So this side is approximately 16.0028. Now let's go ahead and find A or B. We can use the law of sines now since we have a complete pair. Okay, so how about we find angle A, find big A. So using the law of sines, we're going to set it up as follows. Since we're looking for big A, we're going to use the following format. We're going to go sine big A over little a. This is the incomplete pair, and then the complete pair is going to be the c's. Sine big C over little c, which is 6. Let's use the variables first. Sine big C over little c. When we apply the value of our measures, we are going to have sine A over little a, which is 8, equals sine big C is 89 over little c, which is 16.0028. To get sine A by itself, we'll multiply both sides by 8. All right, and then we're going to have sine A is approximately, let's put this in our calculator. We'll have sine 89. Well, let's put the 8 there. 8, and then parentheses around that parentheses 8 times sine 89. Divide that by the denominator, which is the answer we got before. Let's just call that back up. Enter. So we have 0.49983. Okay, so sine A is 0.499835. Now to get A by itself, we'll take the inverse sine of both sides. So let's go ahead and do that. So we're going to take the inverse sine of sine A. So inverse sine of sine A is approximately the inverse sine of this decimal value that we got before, 0.49935. This two cancel out, and then we're going to have A is approximately, let's go ahead and compute what the value is. We just take the inverse sine of our answer, and we'll get 29.9891. So angle A is approximately 29.9891. All right, and then last but not the least, we're going to look for angle, we're going to find angle B. Let's go ahead and find big B. Now, in order to find big B, we don't need to use any complicated formula, okay? Because we have two interior angles already, so we can make use of elementary geometry, namely the triangle angle sum theorem. Okay, so let's go ahead and apply that there. To find big B, we're going to use the expression big B is equal to 180 minus the sum of the other two angles, 29.9891 for A plus 89 for C. Okay, so plug that into our calculator to find the value of angle B. So it's going to be, let's work it out, 180 minus, don't forget the parentheses, the answer we got before, plus 89. All right, and our answer will be 61.0109. Okay, so B is approximately 61.0109 degrees. All right, so let's organize all our measures. For the test, I would like you to round to 3 decimal places. So let's go ahead and do that here. Little c is 16.003. Big A is approximately 29.989 degrees. And big B is approximately 61.010 degrees. Actually 011, because we have to round up. Okay, 011 degrees. And that's the measure of the triangle if it's solved completely. Okay. All right. Now let's go on to question number 2, if I can box this answer. All right, there we go. Let's take a look at question number 2. We're going to be doing the same procedure. We're going to be solving another triangle. So for number 2, what if we have little c equals 18, little b is equal to 17, and little a is equal to 30. Okay, so we're still trying to solve the triangle, just like we did with number 1, solve the triangle. All right, so for this one, let's go ahead and draw a sketch of the situation. So let's draw it like that. Call that side B, call this side C, and call that side A. Okay. All right, let's label the angles. This is angle A, B, C. Big C is little c, 18. Big A, this is little a 30. Big B, this is little b 17. Okay, well, to solve this triangle, basically find the measures of the three interior angles. What type of problem is this? This is an S, S, S situation. Okay? Side, side, side. In order to solve this, we have to use the law of cosines. Since we're not given any angle, we can pick any of the three variations of the law of cosines to use here. Okay, so the variation I'm going to pick is the one that starts with A, because that was the first letter of the alphabet. Nothing really important about that. A squared equals B squared plus C squared minus 2BC cosine big A. Okay? So what will that help me find? That will help me find big A. Okay? All right, let's go ahead and apply this formula to this problem. We're going to have A squared is equal to 17 squared. Actually, we already know what A is. A is 30, right? So let's put that in. So we'll have A squared is 30 squared is equal to 17 squared plus 18 squared minus 2 times 17 times 18 cosine A. All right. To get cosine A isolated, let's subtract 17 squared and 18 squared from both sides. So subtract 17 squared and 18 squared. Using the symmetric property of equality, I can switch this equation around. I'll have negative 2 times 17 times 18 cosine A equals 30 squared minus 17 squared minus 18 squared. Okay, and then we'll divide both sides by the coefficient of cosine A. So divide both sides by negative 2 times 17 times 18. And this by negative 2 times 17 times 18. That cancels out. And then we have cosine A is equal to this expression. Let's evaluate what that expression is with our calculators. So we're going to have parentheses. Don't forget to group your numerator in parentheses. 30 squared minus 17 squared minus 18 squared divided by negative 2 times 17 times 18. Okay, go ahead and do that. Enter. We get negative 287 over 612. Okay, let's go ahead and write that down. It's negative 287 divided by 612. Let's try that again. 287 divided by 612. Now to get big A isolated, what we'll do is we'll take the inverse sign of both sides, okay? So A is basically going to become the inverse cosine of this expression right here, negative 287 over 612. All right, let's plug that into our calculators, see what we get. The inverse cosine of our answer for big A will get 117.966. All right, so angle A is approximately 117.966. All right, let's put that in our triangle, 117.966. Now let's go ahead and find another angle. We can look for angle B next. We can use the law of cosines to find angle B applying the second variation, but this is a long process. There's a simpler formula we can use. Do you know what that formula is? It is a law of sines, okay? We can use the law of sines now because we have a complete pair and an incomplete pair. So what we're going to do next is we're going to find B, okay? So to find B, the formula we're going to use is sine B over little b, the incomplete pair, and a complete pair, sine A over little a, okay? If we apply this formula to this scenario that we have, we'll have sine B that we're looking for over little b, which has a measure of 17, equals sine of A is 117.966 over little a, which is 30. To get sine B by itself, we'll multiply both sides by 17. 17, 17. This 2 cancels out. And we'll have sine B equals, let's plug that expression into our calculator. So we're going to have, in the numerator parenthesis, 17 times sine B, sine, wrong function, times sine B, which is the answer we got before. Let's insert that, close it, divided by 30. Okay? So, okay, I'm missing the parenthesis. Let me see what I did here. Okay, I didn't close my numerator, so let's go ahead and do that. And our answer is going to be 0.500493. Okay, so sine B is 0.500493. So 0.500493. And then to get B by itself, we'll take the inverse sine of both sides. So we have big B equals the inverse sine of this numerical value that we got when we evaluated this expression, which is 0.500493. All right, now to find B, we just use a calculator again to find the inverse sine of that value we got. So let's see, inverse sine of the answer that we got before will tell us the value of angle B, which is 30.0326. 30.0326 degrees. Okay, now we have the second angle. Let's put that in. Angle B is 30.0, let's see what it is again, 0.326. Now to find angle C, we don't need to do much work. We can just use elementary geometry to figure out big C. Okay, so big C is going to be 180 minus the sum of the other two, 117.966 plus 30.0326. Okay, plug that in our calculator to yield the approximate value of angle C. So we're going to do 180 minus parentheses. Don't forget that parentheses is really important. 117.966 plus this result here, and your final answer is 32.0014. So big C is 32.0014 degrees. All right, so let's organize all our results and round it to 3 decimal places. Big A is approximately 117.966 degrees. Big C is approximately 32.001, and big B is approximately 30.033 degrees. Okay, so there goes the angular measures of your 3 triangles.